Hello, everybody. Sorry I'm not here at school today. I'm not feeling that well, and my wife told me that I was taking today off so I get better. So hopefully you did well on the quiz. Everybody should know how to done very well on it. So we're just going to move on with mutations. So basically, we're just going to look at how the different changes in DNA sequence can lead to different changes in the protein and whether that mutation is important or not. The first thing you should do is read this thing here at the top so you can learn what the different mutations are like. And then at that point, you should start working on the sequence. So this is basically the same thing you did with your quiz. You got your DNA sequence. We are just changing it to the messenger RNA. So you would just go along here, and I don't know if it'll let me type here or not. Let's see, A for the T, U for the A, and G for the C. And then you probably want to put a slash in between every three letters so that those codons are marked out. And you're just going to go through and do all the rest of the letters the same way, just like you know how to do. Then you're going to plug AUG into the codon chart. And if you don't remember how to do that, I linked a video in this Google Classroom so that you can watch how to do that. But hopefully you know how to do that. And when you do that, it will come out as MET. And you might want to just put a dash in between there. And you can do that above here. If you just want to use dashes instead of slashes, that's okay. Anyway, you're going to do, let's see, there should be 1, 2, 3, 4, 5, 6 total amino acids. If you come to a stop at any point in this, don't move on. Just write stop and you're done with this sequence, because that will happen with some of these. All right, so this first one is just the original sequence. So it's just what it should be to have a good functional protein. In the second one, they are going to change it up a little bit. So there's going to be a change here. So do the sequence, and then you're going to do the amino sequence, and then you're going to see some sort of difference between the two. So depending upon what difference you see, look up here, and that will be what it's called. And then you just write that, what's the effect. Generally, if it has a stop in the middle of the protein, you can say that basically it's not a functional protein at any point. If there's another type of mutation that occur with these insertions and deletions here, when you add a base or subtract a base, so if you add a base in here, that's going to shift the reading frame over one. So you're actually going to have like one extra amino acid. You can't read that in the codon chart, so it's just done. So if you have any extras, it's just done at that point. You have to have 3 to be read correctly. That's going to change all those proteins, so your protein's not going to work either. Another thing that can happen is one could be deleted, so you got one less, so everything shifts in this direction. So you're going to end up with 2 extras over here, but that's not enough to put in your codon chart, so you can't do anything about that. All right, so you're going to go through and do sequence 1, 2, 3, 4. I take that back. Do not do sequence 4. Don't bother doing that. And do sequence 5. This sequence here at the top of the paper here, that is the exact same one as the sequence up here at the top here. They just didn't want you flipping the papers around, but there's no reason really to do it because you could just flip it around and write it down anyway. So you can skip that one. So you don't have to do these two here. You can just move on to the last question on sickle cell anemia. Try to do this one because this is the one you generally will see on the state test. So it's a good one to try out to do. Anyway, this is due for a grade, so make sure you get it done. And if you don't get finished, it's homework. If you're doing this at home, it's not homework. You're at home already. Just get it done and get it turned in. All right, that's all I got. Hopefully I'll be better and be back with you tomorrow. All right, that's it. Bye.